This is a high-level diagram of the GSN to testnet architecture. And essentially what's happening is, you have on one side relay client code running inside, the client side for your dapp in a browser. It's just like a TypeScript library, and it selects a relay. It would like look up a relay. In local development, it's just like hardwired the test relay that we set up for you, and it takes. We set it up with a small test ETH balance, and in a real setting, let's say on mainnet, then if this list of preferred relays for your dapp, if it fails, then this is where sort of a centralized relay registry mechanism comes in, and it falls back to that and tries to route your meta transactions through other relays that may be more expensive for your dapp, but you don't have an availability issue. And you find a relay, that's available, and then essentially like what the relay does before it signs and pays for the transaction, it will just check with a relay hub contract with a view function. Is there a is the paymaster willing to refund my gas fees? And the relay can say, I want like only the base of my gas fee, or maybe I want a markup of it because I want to receive transaction fees. That's totally configurable, or maybe like your relays for your dapp wouldn't be charging transaction fees for your dapp, but maybe they will charge transaction fees for other dapps. We can sort of play with different configurations. And what happens is after the relay hub confirms with the paymaster, or actually, like the relay server is sort of asking in view mode the relay contract, like, is this paymaster, does it have like an ETH balance that allows it to make this commitment to pay me back my gas fees? Assuming everything checks out, then a transaction is signed. It's immediately returned back to your dapp client. And then, the relay server tries to transmit that to the blockchain as soon as possible. And there's a mechanism designed to try to prevent it from censoring things if you're using an untrusted relay. And eventually this meta transaction gets unpacked in a trusted forwarder contract that just checks that the original assigner did actually assign, and we can then substitute message sender for this underscore message sender function that does exactly the same thing. But in this case, it says this is who I know signed the transaction, because the message sender, if you didn't do that, would actually be the relay, because the relay was paying for the transaction. So in a local environment, all this is sort of abstracted for you by the development fixtures that we created. So it just somehow magically works, and you can test your code through it. It's pretty transparent, or at least that's what we're striving for. In a real setting, there's a bit more going on. You can, there are the relay participants, and there are these paymaster contracts that you can set up for your dapp, or you can use a paymaster contract that exists for other dapps. So there are all these different models, and trying to build something that's useful for the largest number of people with different use cases. Is there any questions, by the way, Austin?
I think I like the default method also. Like, I like that there is a default method, and I don't have to think about a lot of the complicated things until it gets to the point of like, oh, what about this? And I need to, right? Like, I want to make it work first, and then kind of like worry about the details later. Like, or when I do need them, right? Like, there's a moment when I'm going to be like, okay, I actually want to like learn everything I can about this paymaster, or run my own, or however it works. But right now I just want it to work, right?
Exactly.
Do you want me to? Yeah. Okay. Yeah. So if you want, I can take over the screen when you're ready.
Yes. Let me do that. Let me stop sharing it. Okay.
Okay. So let me just do like a normal, like basically we'll bring down scaffold-eth. It will work. this probably isn't the best way to do it in the long run. Like, I think I want to do like a better video of a GSN base, but this is basically taking the scaffold-eth base and plugging GSN into it. So we pull down scaffold-eth and we run the normal install, and that's going to take a little bit. Let me get that started. We're going to have to do a yarn start and a, whoops, what did I do there? And we're going to need to also run our chain. So we'll have.
Do you have GSN packages installed?
I will also need to install the GSN packages. Yep, I'll go through you guys' steps as soon as I get through these steps. So that'll be the first step, is installing GSN. It's slower when you're like streaming video and recording video and talking. So it's like this installation is just going to take a little bit longer than usual. Bring up the code and we can look at it and see that there are kind of these. Ooh, let me make sure I did that right. Okay, it's up, and if we do a yarn, let's see, we'll do a yarn run chain in one and a yarn, oh gosh, sorry guys, and a yarn start in the other one. So this will bring up our React dev server. This brings up our blockchain. And now, okay, so let's head into packages Bidler, and we are going to install GSN, right? So I'll do a yarn add OpenGSN. I'm not sure if I need to restart my server, but I'm going to just in case. Oh no, that's the front end. This would be Bidler. I'll restart my chain after I install OpenGSN. I don't even think I need to, but I'll do it anyways, just in case. Yeah, I think that's more for compiling contracts. Oh man, so slow. Okay, so we're gonna want to edit our contract right away, right? There we go. Okay, so we have OpenGSN installed. We have our chain running right there. We have our dev server running right there. And the last thing to do is just a yarn run deploy, and that will compile our contracts and ship them to the front end. And this is basically just like scaffold-eth. This isn't anything, we haven't done anything cool with GSN yet. Okay, so really we're waiting for this front end to come up. There we go. Okay, that should basically bring everything up. There we go. Okay, so we have a contract deployed. It's a smart contract. We haven't done anything else. And basically with scaffold-eth, the first thing it tells you to do is go edit the contract to like change a spelling error. And that was just a way to like get people to like change the contract and see that things change. I think that what we'll do is, ooh, whoa. Those are the changes from the other one. Okay, here's our contract. There we go. Normally what you do is you change this smart contract right here, and then you do yarn run watch. And it just starts watching your contract for changes, and then you see in the front end that your contract has recompiled, redeployed, and hot reloaded right here, which we'll see in a second. All right, nice. Now we have a smart contract wallet. So there is this function call to update the owner right here that does not take any value. It's just changing state. So this is a perfect thing to use GSN for. Technically, this guy with $0 should be able to take his address and paste it in here and hit go. Right now it's going to say you don't have enough funds. Okay, so now if we want GSN in there, what do? We install GSN, first thing. Second is we go to our contract and we need to bring in base relay receipt, right? And we need to inherit it. And that will come with the need to set this forwarder function. Okay. So we're bringing in the base relay and we're setting the trust forwarder. I'll save that. See if that deploys, compiles and deploys. Later on, we will need to call that set trusted forwarder on our deploy script.
And the message sender?
Oh, right. That's a, yep. And then what we get to do, and this is kind of since the message sender will change if it's a meta transaction, it won't actually be the message.signer, it will be the person who signed the meta transaction. We'll replace this message.sender here and this message.sender here with underscore message sender, a function call that is probably calling something here, right?
Yes.
Cool. All right, let's compile and deploy that. Okay, now we're going to need to have a GSN relay up and running. So we're going to add this GSN. So we're going to add something to our packages to make it. You guys said GSN start. I'm just going to change it to GSN. So if I do a, right here, if I do, let's see, if I do a yarn run GSN, hopefully this will, oh, what did I do wrong there?
GSN is a standalone one. Just name it something else.
Oh, I need to do GSN start, right? Wait, it is.
Yeah.
It is.
Oh,
Maybe
wait a
it's
minute.
a circular loop. The fact that you could, you do start.
You name the command the same way you like.
Yeah. This is
Just in case,
exactly.
just in case. I'll put this in here, just in case. Yarn run GSN start, you think? No. Wait. I'm in the wrong folder. My bad. Come on. My bad. Wait a minute. So why did I install GSN into, I probably maybe shouldn't have done that. I maybe shouldn't have installed GSN in the Bidler folder. Did it need to be installed in the React app folder? Kind of, there's two packages, right? There's a React app and a Bidler. I don't know. I think this actually works. So
I think it should be. No, it should be in the React app, yes, because it is a provider.
But it's, I mean, it works. So
it works
It does
kind of
not
weird
really
because
matter.
of the way
workspaces
work.
works. Yep.
Yeah.
Okay. I'll make a note to not do that next time. I'll make a note to install it.
Okay, it should, you install it correctly. It should be in the React app.
Yeah, I think I did it in the Bidler folder, but it's working. We're good. I made a note for myself next time. Okay, so now what do we have here? We've got our blockchain up. We've got our dev server up. We've got our dapp right here. We have our GSN relayer here. Our smart contract almost works, except for we're going to need to call that trusted forwarder. The last thing I think we have in the notes is the whole wrapping the account, which will actually be different when we do a bigger build of this, because we'll want to have the provider that does gasful things, and we'll want to have the provider that does gasless things, and the dapp developer himself should sort of be changing that and kind of navigating that paradigm themselves. Okay, so back to smart contract. We need, what's that? Go ahead, please.
Depending if he has an application that needs both.
Yes, maybe
Test
it needs to be.
applications do need both. Normal applications, I believe, are full gasless. Otherwise, it doesn't make sense.
I'm
gas
not
somewhere.
sure. Like you can see applications, like you can think of applications that would need both. For example, if you do normal transactions that you don't really care about anonymity that much, but once you do care on certain other certain accounts, you care about anonymity, then GSN can provide this anonymity because you don't need to.
Yes.
This is another use case that you can think of, something like mixers, for example.
Yeah. Also hidden counterfactual wallets. So you can calculate the address of a wallet, receive tokens to that wallet, And usually to activate a counterfactual wallet, you would have to send ETH. But if this is a GSN-aware counterfactual wallet, then you would be able to pay for the deployment of the counterfactual contract through the GSN by essentially giving a paymaster a commitment for the contract to pay for its own deployment in tokens. So you could have
you have a bad microphone. Is it only me?
Yeah, your audio is kind of strange. It's kind of like
so strange. Maybe I was talking kind of fast.
And just to update, all I'm doing over here is I'm bringing in the relay provider. I'm setting up the configuration for the GSN. And then instead of just loading up a burner provider, I'm going to do something where I basically wrap all my burner providers with this GSN provider, which will basically just send everything to the relay, I'm assuming, unless there's that config file that we can't change because Ethers doesn't let us change it. So basically everything's going to go through the relay provider. Is that right?
Yes, but it's not only relevant to a burner provider. For example, it can be for injected provider like MetaMask.
Yep, exactly.
So you will repeat this setup again.
You can drop any provider you want.
Right. Right. I think that, yeah, that's a key thing to talk about here is you will want to wrap any provider that you want to do gasless transactions with, right? I don't want to wrap a provider and then do like send of value.
Yes.
Yeah.
Okay, cool.
Sort of, you can, but
but it goes great with burner providers that is supposed to do the same way.
Okay, so now what do we need? Deploy script, right? The last thing we need to do is when our contract, our smart contract is deployed, we need to make a call to it to set the trusted provider or trusted forwarder, which we can see is here, but it's also in the file system. Let's see. Let's find our deploy script for Biddler. And if it is this specific smart contract, this is kind of ugly and hacky. Again, we're just trying to like take scaffold-eth, plug GSN in, see what we learn, and then do this all again a couple times to figure out the right way to do it. But what we're doing here is saying if the contract that's getting deployed is our smart contract wallet, then we want to go get the forwarding address from the file system where it's injected and call a function on it that sets the forwarder. So now when we do a yarn run deploy, hopefully our smart contract now has GSN and has the meta transaction stuff for the update owner function. And we should see we set the trusted forwarder to the right address, and our app comes up at 1D8. Okay, so as far as I can tell, I think we've covered everything. Do you guys see, have you guys seen anything wrong so far, or should we try for the magic moment of updating the updater without any gas?
I think you can try.
Let's go for it and see what happens. Okay, we just did the demo where I went through scaffold-eth and I wasn't able to. So this guy has no money. If we were to check him, he doesn't have any, and so he's going to try to set himself as the owner, which in the logic of the contract is totally allowed. And in our app, it works. Ta-da! Okay, so let's just do that again real quick. So grab another random address and tell him to set the contract as himself, or maybe he can set the owner as that guy. They can do whatever they want now, willy-nilly. This guy has 0 ETH, this guy has 0 ETH. I think that's it, right? We did it. Now we just